Hi there! In this video, I'd like to show you how to find the total area between the graphs of f of x is equal to 9 over x and g of x is equal to x on the interval from 1 to 4. So here we have an example where we actually have the curves crossing over each other in the interval, and that's called intertwining curves. Let's look at what we have so far. So f of x is 9 over x, and if we take and just highlight that a little bit, that is this curve right here, and it actually has another piece of it on the other side of the y-axis, but our intervals from 1 to 4. So I just graphed the quadrant one that applies to our problem. Now g of x equaling x is the line. So we have the line going through the origin with a slope of 1. And on the interval from 1 to 4, we're going to graph vertical lines at the endpoints of that interval between the curves. So I have at x equal 1, we will draw this vertical line, and then at x equal 4. So here when we look from left to right, we see that the blue curve is higher in the plane than the red line from x equal 1 until you get to the point of intersection, and it looks like that's happening at x equal 3. And then from x equal 3 to x equal 4, the red line is higher on the plane than the blue curve. And we can actually verify that by finding the point of intersection of these two curves in that interval. So to do that, we have that y is equal to 9 over x and y is equal to x. To find the point of intersection, we'll just substitute x in for the y, and we have x is equal to 9 over x. Multiplying both sides by x, we get x squared is equal to 9. Taking the square root of both sides, remembering our plus or minus, we have x is equal to plus or minus 3. However, we need to make sure that we stay within the given interval, so our value that is applicable to this problem is x equal 3, which we could tell from the way it was graphed. So we are going to set up our definite integrals and do the first definite integral to find this area, add it to the definite integral to find that area. So we have our integral from 1 to 3 of the blue curve, the 9 over x is higher in the plane. So we'll write that first and subtract from it the red line, the x, dx, and add to it the definite integral from 3 to 4 of, and the next part, the red line's higher in the plane. So we'll write the x first minus the 9 over x, dx. So now we just need to evaluate these two definite integrals and add them together. So let's first look at the integral from 1 to 3 of our, and we're going to write the 9 over x as 9 times x to the negative 1 to get ready to integrate it. So that's equal to, well, the integral of 9 times x to the negative 1, well, x to the negative 1 is a letter base with an number exponent, but the number exponent's negative 1. And remember, that's the case that goes back to the natural log. So I have 9 times the natural log of the absolute value of x, and then minus, for my x to the first power, I can use the general power rule and get 1/2 x squared. And we are going to evaluate that from 1 to 3. Plugging in 3, I have 9 times the natural log of the absolute value of 3 is 3, minus 1/2 times 3 squared, and then subtract off of that 9 times the natural log of 1 minus 1/2 times 1 squared. So I have 9 times the natural log of 3 minus 9/2, and then natural log of 1, remember that's 0. So that's 9 times 0 is 0, and then 0 minus 1/2 is negative 1/2, and minus negative 1/2 is plus 1/2. And I get 9 times the natural log of 3. Minus 9/2 plus 1/2 is minus 8/2, so that's minus 4. Now remember, that's just the first part. We still are going to take the definite integral from 3 to 4 of our x minus 9 times x to the negative 1 dx. And that's 1/2 x squared minus 9 times the natural log of the absolute value of x, evaluated from 3 to 4, and we have 1/2 times 4 squared minus 9 times the natural log of 4, and then minus 1/2 times 3 squared minus 9 times the natural log of 3. So 4 squared 16, half of 16 is 8, minus 9 times the natural log of 4, and then I get a negative 9/2 and plus 9 times the natural log of 3. Here I'm going to take and look at the 8 as 16/2, and 16/2 minus 9/2 is 7/2. So I have 7/2 minus 9 times the natural log of 4 plus 9 times the natural log of 3. Now what we need to do is add this to our other area region, and when we add these together, we take our 9 natural log of 3 minus 4 and add it to 7/2 minus 9 natural log of 4 plus 9 natural log of 3, we get a value of 18 times the natural log of 3 minus 9 times the natural log of 4, and then minus 1/2. And that is in square units, and that is our area. Total area caught between those graphs of f of x equals 9 over x and g of x equal x on the interval from 1 to 4. And it's an example of when you have intertwining curves.